Hi everyone, grab your notebook if you have not already, and we're going to title a new page, Properties of Logarithms. I was really happy last week with the progress check and how well you guys understood the concepts. I was a little bit worried about it, getting it from a video, but you really have been doing great. So let's see if we can keep that going. So properties of logs basically is just going to be a way for us to write equivalent expressions, maybe more simplified expressions. We're going to use them when we start solving log equations, that we can change the way the equation looks and then maybe be able to have an easier time solving it. You're really not going to get the full impact of how important these properties are of logarithms until calculus. So Algebra 2 just really sets the foundation, kind of shows you what it's all about and gets you to practice using them. So we're going to run through the 6 properties, do a little bit of explaining, okay, why they work. And then we're going to kind of end this with a few examples. Taking these notes today, listening and writing them down with me, that's all you're doing. That's all that was assigned for today, was just to listen to the notes. So we'll talk about it at the end if you want to get ahead, but really just stay with me here, take your time, pause it when you need to, because this is all that you need to do. All right, property number 1. This property says that when we take log with base b of the number b, that you always equal 1. All right, so this is a pretty simple property. Let's say we're doing work and we have like log base 3 of 3. Or let's say we have log base 7 of 7. And what we can do with that is we can take out that logarithm and replace it with the value of 1. What we're going to do for each of our properties is we're just going to run through a quick why, or some kind of justification that the property works. So if I change this into exponent form, this means base b to the first power is equal to this number b. And I think when we do that, it's pretty clear to see why this property works. It's the same thing over here. If I take 7 to the first power, it's going to equal 7. Okay, so simple little property, easy to use. We just need to remember that we can simplify at times. All right, property number 2, along the same lines, the natural log of e is equal to 1. This is actually a property that we're going to use more often in our equation solving. If we were to solve an exponential that has an e, we would use a logarithm, and this is a really useful property. So again, just a quick why. Again, logarithms have base e. So if I take this base e that's assumed and raise it to the first power, it will equal this e right here. So check. I think it's pretty easy to see why this works. So these two properties are basically the same. It says that if you take the log of a number and that number is the same as the base, it will equal 1. Let's move on to the next one. Number 3. All right, this property says that log base b of 1 is equal to 0. So it's saying that anytime we take the log of 1, and this could also be, by the way, this could also be that if we take the natural log of 1, we will also get 0. Okay, so from now on, I want you to know that when we talk about these properties of logs, when we talk about log base b, it means that that base b can be anything. So I'm not going to keep writing it with a log and a natural log, but it works for both. Just a quick little why. I think this one's pretty intuitive. When we take our base b and raise it to the 0 power, a 0 power always gives us 1. Same thing over here. When we take e and raise it to the 0 power, it equals 1. So pretty intuitive little property. The log of 1 is always equal to 0. Let's get into our bigger properties here that are really going to help manipulate these expressions. Number 4 is what is called the product property. And what it says is this, that if we have log base b of 2 terms in the input, all right, maybe we see a multiplication dot, maybe we just see like 5x, okay, but it's 2 separate terms. This, by the way, is what we would call condensed to a single log. So you might see directions that say something like write in condensed form. This is what I'm talking about. It's the input is a product, but we have a single log. And what we can do is we can rewrite this as log base b of the first input plus log base b of the second input. And this is what would be expanded as the sum of two logs. And so that's kind of the difference between them, is we can either write something as a single log or we can make it the sum of two separate logs. And I usually would bring this up in class if we were there, but I try to relate it back to a little bit, just as kind of a separate note. I try to relate this back to the exponent properties. That we've talked about properties where we might have the product of two bases, okay, where we take x to the a times x to the b. So here we have the product of two bases. We can condense it to a single base x if we rewrite it as a plus b. So in a way, it's like we're using this exponent property, but we're using it backwards. To go backwards, we write the two bases as the sum. But so anyway, I hope that makes a little bit of sense right there, that we are basically using the same thing but backwards. All right, I want you to go get your calculator. Pause me if you need to. Get your calculator. And I want to just do a little quick like why, or at least not even so much why, but at least kind of proving that this really does work. So what I'm going to do is I want you to figure out log 12. All right, I'm just going to use a base 10 log just so that we can easily use our calculator for this. So I type this in and I'm going to get log 12. I don't really care what this equals. The point of it is it equals 1.079. So from here on out, in this example, 1.079 is what I'm going to call our magic number. I want you to think of two numbers that multiply to make 12, okay? Go ahead and think about it. Give me two numbers that multiply to make 12. Well, regardless of what you're thinking, we'll get there, okay? I kind of thought of, let's say, log of 6 times 2. Now, I hope you would trust me that, I think it's common sense that if you type in log of 6 times 2, you're obviously going to get the same number. But what's interesting here is we can expand this into the sum of two logs if we write it as the log of 6 plus the log of 2. And that's where I want to come into our calculator and type it in as the log of 6 plus the log of 2. And you then see, yep, we got our magic number 1.079. Now this is going to work for any two numbers whose product is 12. So if I take log of 4 plus log of 3, if that's what you were thinking of, 4 times 3, yep, we get the same thing. And even down to, this should be pretty easy to see, but log of 12 plus log of 1, right? Because 12 times 1. So we can see that this property does hold true, in fact, that we can take the sum of two numbers whose product is equal to the 12. All right, so let's go on here to property number, what are we on here? Property number 5. And this is going to be the quotient property. And before I do it, I sometimes, again, like to relate this back to our exponent properties. And again, we're going to almost apply these backwards, if you will. So when we have two bases and we divide, what do we do again to condense this into a single base? Well, we make it a single base x, and what do we do with the exponents? We subtract. So we're going to go backwards now. But you will see, I don't think it's going to be surprising that we're going to see subtraction in this example. So this says that when I have log base b of the quotient of two terms, all right, again for terminology, this side is condensed to a single log. And what that equals is log base b of the first term minus log base b of the second term. And this is what we would call expanded to the difference of 2 logs. And so that's what you're going to see in your directions. It's going to a lot of times say something like write as the sum or difference of 2 logs. That basically means to expand. All right, just really quick in the calculator. Can we think of 2 numbers that are going to divide to make 12? Okay, we have an infinite number of possibilities, but I think maybe what we're most thinking of is maybe 24 divided by 2. So let's go into our calculator and let's see if we take log of 24 and I divide that by log of 2. Let's see if we get our magic number. Oh, do you see what I did right there? Completely don't do that. I'm sorry. I was not expecting that to happen. If we take log of 24, what did I do wrong? Okay, what did I do wrong? You're exactly right. I need to do minus log of 2, right? And then I get my magic number, 1.079. Exactly, in all my times of doing this, I've never actually done that before, so sorry about that. But we can see that this is equal to log of 24 minus the log of 2. And here's our last property. But it's probably good that I did that in a way, because what a lot of people think you can do is that you can take log of the first number and divide it by log of the second number. So if nothing else, I kind of hope that that showed you that we cannot just take the log of each number. Okay? All right, property number 6. This is what's called the power property. And this one is super, super useful. So make sure it's our last property, but make sure you continue to listen, because this one we're going to use all the time. And this says that if we have log base b of a number raised to a power. Okay, now this is important too, because maybe it's not quite as intuitive that this is what is condensed form. But what I want you to notice is the powers are written as exponents. The powers are written as exponents. And what this little property says that we can do is that we can rewrite it, and we can take the power and we can bring it down in front and write it as a multiplication factor. Okay, and we can make it look like this. So we're going to spend a lot of time bringing powers down or maybe putting them back up as exponents. But this is important, okay, for terminology's sake, is this is what expanded form is considered, where the powers are written as factors. And when I say they're written as factors, that's assumed to mean that they are written as multiplication factors. Okay, so you'll see that in the directions where they might say, write powers as factors, and that's what that means. Just a quick little, let's just kind of prove this in our calculator. Let's say we have the log of 16, okay? Could we write 16, could we rewrite that as a base to an exponent? And we can. So we could write this as the log of 4 squared. So let's just stop for a second. Let's go into the calculator, get rid of that. If I take log of 16, there's our magic number, 1.204. It should be pretty intuitive to see that if I rewrite it as 4 squared, I'm also going to get my number. But what this property right here says that I can do is I can bring down the 2 in front and rewrite it as 2 log of 4. And that's what I want to prove to you in the calculator, is that if we take 2 times the log of 4, we in fact get the same thing. So it's just a matter of convenience, what we're trying to do. Sometimes I like it written as an exponent. Sometimes I like it written as a multiplication factor. But we'll probably end up using these last couple properties the most. Now what I want to do is I want to end here with some examples. And I'm going to do a few more examples than I maybe would if we were in class, just because I'm not here to help you right away. So example 1, we are going to expand each logarithm. Okay? We are going to write powers as factors. And we're going to look at 3 different problems under these directions. All right? Let's say we have something like log of ab squared. And so here we'll just kind of work with a base 10 log. So first thing that I want you to do is I want you to understand that it is not just about getting the answer. It is about using the properties. You can use one at a time per step, and you have to show your thinking with this. So the first thing I'm going to recognize is that I have the product of two terms. So I'm going to expand this out and make it log of the first term plus the log of the second term. And this is the product property. I'm not going to make you write out the properties that you're using, but I will be able to tell because, like I said, you get one at a time. I don't care if you see the b squared already and you want to do it. You have to do this step by step. It is fantastic practice for what's coming at you next year in pre-calc when everything has to be done step by step. So then what I can do is I can take the 2 and I can bring it down front. So log of A plus 2 log of B, this is the power property, and I just give it a second look and I make sure that I'm not missing properties 1, 2, or 3, okay, where we maybe take the log of 1 or we have the same input in the same base, but I don't, and so this would be the final expanded form. Pretty easy example right there. Good one to get started with. Okay, say I have log base 2 of x to the 4th divided by y, and we're going to expand. So the first thing I'm going to do is I'm going to use the quotient property and take log base 2 of my first term minus log base 2 of my second term. So this is the quotient, and I'm going to start abbreviating property. Then I look at it and then I recognize, okay, I can bring down the 4 and write it as 4 log base 2 of x minus log base 2 of y, okay? And this is the power property. So again, another little easy example. Let's finish with one that's maybe going to be just a little bit more to it. You're going to have definitely a mix of both in your homework. Log base 3 of 9 square root of x, and we need to expand. So when I see this, the first thing you should recognize is that we have the product of two terms. So I'm going to write this as log base 3 of 9 plus log base 3 of square root of x. Okay? Product property. Now, it could be, you could probably look at this and kind of feel like you're finished, but the numbers that I have given you could be rewritten as a base to an exponent. And if that's ever possible, we should keep going and we should replace the 9 with a 3 squared, because if we can write it with an exponent, then I can do more with this, okay? Well, how can we rewrite the square root of x? Well, we could rewrite it as x to the 1/2. And so we could write the numbers as an exponent. I'm not really using a property there, so I'm just going to kind of keep going. So what I can use is the power property now, and I can make this 2 log base 3 of 3. And I can make this, if you bring it down, is 1/2 log base 3 of x. So I'm using the power property. And finally, we need to give this another look before we feel like we're finished. And what I notice right here is that log base 3 of 3 is equal to 1. And so that little property right there can be a little sneaky sometimes and easy to overlook. So I can make this first part 2 times 1 plus 1/2 log base 3 of x. Okay? And what we're using is property number 1. I don't really have a name for it. It's just basically that log base b of b is equal to 1. And this would be right here, this would be my final. And so again, what we're doing is we're just doing exercises that let us use the properties and interact with them and get used to them. But what we're saying is that this is the exact same expression as this. How we're going to use them, now that's going to depend down the road, okay? But we have ways to manipulate these to make them potentially easier to work with. All right, last set of examples. Stick with me here. Example 2. Well, let's try the other way, and let's condense each expression to a single logarithm. So let's say we have 4 log of 3 minus 4 log of 8, okay? So we kept seeing when we were expanding that our power property was one of our last properties to use. Well, we're going to reverse that in a sense, and we're going to basically make our power property is going to be one of our first properties we use. So if we ever have these multiplication factors, we need to first write our factors back as exponents, because in condensed form we write our powers as exponents. And so again, we're using our power property. Well, now what I see is I have the log of 3 to the 4th, and I have minus the log of 8 to the 4th. I need to condense this to a single log, okay? It is the single log of 3 to the 4th divided by 8 to the 4th. And the reason I kind of made a big deal about that, okay, and is because the big misunderstanding that people do is they want to make it log of 3 to the 4th divided by log of 8 to the 4th, and that is incorrect. We are condensing it to a single log. And so now from here, I mean, I suppose I would be okay with that being your final answer, but a lot of times what you're going to see is rather than taking 3 to the 4th power and 8 to the 4th power, we could then pull out the exponent and make it 3/8 to the 4th. Okay, so that's just kind of using an exponent property right there rather than a log property. And that I would leave as my final answer. And it's a pretty easy example. Let's look at something else. Let's pull in a natural log. You know, I kind of missed the boat on the last examples as I didn't do a natural log, but like I said, these properties hold true, right, for any type of log. And again, this ln right here, it's not an in, but it stands for the natural log. So again, same thing. I'm going to start and I'm going to bring up the power and make this the natural log of x to the 1/2 plus the natural log of x to the 4th. And it really doesn't matter if the 1/2 is in the parenthesis or out of the parenthesis. That doesn't matter. Power property. So what can we condense this to? If we have the sum of 2 logs, I can make it a single log of the product of the 2 terms. So this is the product property. And then a lot of times the point of condensing it is I can sometimes maybe work with these terms more, okay? If I had an x and a y, I would be finished. But if I do have the same base, well, I can use an exponent property, right? That x to the 1/2 times x to the 4th, the base stays the same, and we add our exponents. So this is just an exponent property, right? X to the a times x to the b, I can add my exponents and condense it to a single base. And I can rewrite this as natural log of x to the 9/2. All right, and it doesn't really matter if you make it natural log of x to the 9/2. That honestly doesn't really matter. But that is the same thing. So again, take a look at this. This expression we started with is the exact same thing as this. And it's just interesting how much you can manipulate these while keeping the expressions equivalent. Part C, last example. Log base 3 of x squared minus 4 minus log base 3 of x plus 2. So I start this time, and I don't see any numbers in front, so I do not need to use the power property this time. Instead, what we're going to do is, because of the difference of the 2 terms, I'm going to make it a single log base 3 of the first input x squared minus 4 divided by x plus 2. Okay, so I started with the quotient property. Now, again, a lot of times we can simplify. Okay, it just all kind of depends on if you have the same base. You just have to take a look. You have to just kind of know. And so these are rational expressions. We do not individually cross out the 4 and the 2 and the x's, right? This kind of makes Mrs. Shape cringe here. What we do is we factor and we see if we can simplify any of the factors. So x squared minus 4 can factor in x plus 2 and x minus 2. Well, in the denominator, we have x plus 2. So instead, if we factor maybe then we could simplify the x plus 2's. Now, for some of you technical people, you are exactly right. We need to be careful. We need to state that even though we're crossing out the x plus 2's, we always need to know that x is not allowed to be negative 2, okay? But with that being said, we can go ahead and simplify this and rewrite it as log base 3 of x minus 2, all right? I'm going to be honest with you. I don't know in the homework if I kept saying what x cannot equal. I just know some of you guys get very technical and you would have asked about it. And yes, that is true. We can simplify it to log base 3 of x minus 2 as long as we know that x can't be negative 2. But again, look at the difference between what we got and what we ended up with, okay? And when we go to solve an equation, we're going to choose to solve this equation down here because it's more simplified. So that's it for the examples. Thank you for tuning in all this time. There's still so many more examples I wanted to run you through, but I didn't want these notes to go on for 45 minutes. So you are done for today, okay? So Monday today, all you did was the notes and copy into notebook. I keep reiterating that because we're going to end this year with a test over exponentials and logs. You really need to have this stuff written in your notebook so you can go back to it. Now, Tuesday, I kind of said this on the syllabus. If you want to get ahead, you are going to work on levels 1 through 5. I think it's page 14. Okay. I'm kind of doing this off the top of my head, so if I'm wrong, I'm sorry about that, but I'm pretty sure it's page 14. So it's completely up to you. If you want to get a head start, you can work on levels 1 through 5. You really want to try to do them on your own. And the answer and my work are in the answer key folder. Okay? My answers and my work are in the answer key folder. So work out the problems. First, see if you got the answer right. If you did not get the answer right, you can go ahead then and take a peek at my work. And you should probably take a peek at my work anyway, because I want you to understand that you really got to go step by step. Okay, enough from me. Good luck. Let me know as always if you have any questions. Bye.